Hello class, and welcome to day 2 of section 1-3, and we are going to be talking about weighted averages. By the end of today's lesson, you will be able to solve mixture problems as well as uniform motion problems. So a mixture problem are problems where there are two or more parts being combined in different quantities to make a whole. So you can think of this as a recipe. If you are doing some cooking, you're pouring in sugar and you're pouring in flour and chocolate chips and oil and everything that you need to make your chocolate chip cookies. And the mixture problems are going to talk to you about how much you need to make the proper recipe. Uniform motion problems are the problems that specifically deal with speed of an object and two objects and how they are moving within relation to each other, and the equation that we're going to be using for that is distance equals rate times time. So when we get to those problems, I will remind you of that equation. We're going to start with the mixture problems, and a few things about mixture problems. It's much easier if you organize the information into a table. You do not have to do this, but again, it'll be easier on your homework assignment and on the study guide, tests, etc. These tables will be provided for you if you would like to use them. When you're setting up the table, a couple things that will never change. In a mixture problem, the mix is always going to go in the bottom, and the total is always going to be up in this top right. The other quantities and labels are going to change from problem to problem, but those two are going to stay the same all the time. In the case of this problem, to make trail mix, a company mixes peanuts and raisins into its product. They sell the mix for $5 per pound. The peanuts cost $2.10 per pound, and raisins cost $7 per pound. How many pounds of raisins should be added to 5 pounds of peanuts to make the trail mix? So now to fill in the rest of this table. Over here is always what you are mixing. So in this case, it's peanuts and raisins. So we're going to fill in that information into our table. So we're taking and we're combining peanuts and raisins. The other one are going to be your units or your labels. In this case, we're talking about pounds and dollars. Doesn't matter which order you put them in. Since it lists money first, I'm going to say money and I'm going to say pounds. So now we need to go in and fill in what we know. So in this box, it would be the amount of peanuts, or how much peanuts cost. For the problem, it tells us that that is $2.10. This box would be how much raisins cost, which is $7, and this box would be how much the mix costs, which is $5. The next part is for pounds, what information we know about how much of the particular items we have. So it asks how many pounds of raisins, so that's what we're wondering, that's where our X is going to go, should be added to 5 pounds of peanuts in order to make the trail mix. So the last 4 boxes are currently blank, so we're going to have to work out how we are going to fill them in. First, dealing with this mixture. We know we have 5 pounds of peanuts, and we're combining it with our pounds of raisins. When we combine things, that means we're adding. So we've got our 5 plus x, or x plus 5. Doesn't matter which order you write it in. Now, to solve the problems, the process is always going to be the same. Multiply the values going across to get this total column. So in this case, it would be 2.10 times 5. The next column would be 7 times x, or 7x. And our last row is going to be 5 times x plus 5. To solve then, you are going to want to combine these values into your equation. It's always going to be top plus the middle is equal to the bottom. So in this case, we've got 210 times 5, which is 10.5, plus 7x is equal to, now we're going to do the distributive property, giving us 25 plus 5x. And now we end up like yesterday with an equation where we have variables on both sides. I'm going to combine my variables first by subtracting 5x from both sides, giving me 10.5 plus 2x is equal to 25. I'm going to next subtract my 10.5 from both sides, giving me 2x is equal to 14.5. And finishing out, I'm going to divide both sides by 2, giving me x is equal to 7.25. So within the context of the problem, my x falls under pounds of raisins. So I would label this pounds of raisins. So again, the table helps us organize the information that we need to solve the problem. Another example of this. A recipe has a dough that is 50% peanut butter, and recipe B has a dough that is 80% peanut butter. How much of each dough should be used to make 100 ounces of a dough that is 68% peanut butter? So we want to go through and we want to label our table again, always starting with mix and total. In this case, the two things we're combining are recipe A and recipe B. Our values or our labels are going to be the percent and ounces. So we've got percent and ounces. Filling in our information, we know that recipe A is 50% peanut butter and recipe B is 80%, and we want our mix to be 68%. So we're able to fill in all of those. It also tells us that we want 100 ounces of the mix. So now we have to figure out how to fill in the remaining part of our ounces. We are looking to figure out both of these quantities. So it doesn't matter which one you pick as your variable. So I'm going to just say A is my variable. To figure out B then, if A was 10, for example, then in order to get from 10 to 100, I would need 90. If A was 15, for example, then I need 1585 to get to 100. So in order to reach that total, I'm taking the total and I'm taking off whatever we have of A. So if you're given the mixture total and you need to find both, you're going to have to pick one variable and then the total minus that variable for the other one. Those could flip-flop if you wanted them to. The answer will work out the same either way. Then we're going to follow our process, which is to multiply across to get that final column. So we've got 50x, and then we've got 80 times 100 minus x, and then we've got 68 times 100. In order to solve the problem, we need to set up our equation by adding the top two and setting them equal to the middle one. So I've got 50x plus, using distributive property, 8,000 minus 80x is equal to 6,800. Both of our variables are on the same side this time, so we're going to go ahead and just combine those like terms, which is going to give us 50 minus 80, giving us negative 30x plus 8,000 is equal to 6,800. Using SAD MEP, I'm going to go ahead and subtract 8,000 from both sides, giving me negative 30x is equal to negative 1,200. Dividing both sides by negative 30, I end up with x is equal to 40. Now I need to make sure I answer my question, which was how much of each dough do we need? So we figured out x, which is A. So recipe A, we need 40 ounces. We want to get up to 100, so for recipe B, I have to do 100 minus 40. So of recipe B, I need 60 ounces. Go ahead and try this mixture problem on your own. setting up the table and working through to solve, you are going to find that you need 12.5 gallons of solution B. We're going to switch gears now and look at the uniform motion problems. Again, as I said on that first slide, we're going to be using the equations distance equals rate times time. You'll notice our table is a little bit smaller. We've eliminated that mixture part because we aren't actually combining these values in the same way. Our distance equals rate times time equation is always going to go in this top portion. So distance is equal to rate times time. With this problem, we have Ann and Bob are starting biking in opposite directions on a circular trail. The trail is 5 miles long. If Ann travels at 12 miles per hour counterclockwise and Bob is traveling at 18 miles per hour clockwise, how long until they meet each other? So the two people involved here are Ann and Bob. To give you a quick visual, if we have a circular trail, Ann is going to be leaving and going counterclockwise, while Bob is leaving and going clockwise, so the opposite direction. They're going to be traveling different distances, but our total path here we know has to be 5 miles. Other information that the problem gives us is the speed, aka the rate at which they are traveling. So Ann is going at 12 miles per hour and Bob is going at 18 miles per hour. We are trying to figure out how long, how much time until they meet. So what we do know is if Ann's going this way and Bob's going the other way, at one specific point they will meet up. So that is the same amount of time until they meet up. Similar to the last problem, we're going to multiply across to get that final column. So we've got Ann's distance is 12x and Bob's is 18x. Now, on these problems, you can add. For some of them, you'll need to add that final distance. So in this case, we know that they need to travel 5 miles. We're going to go ahead and add them up, just like we did before, to solve our problem. So Ann's distance plus Bob's distance has to equal the total of 5 miles. When I combine those two, I get 30x is equal to 5. Solving that problem, I'm going to go ahead and divide by 30, and I get x is equal to 0.16 repeating. To make this a little bit easier, that's currently in hours, so I'm going to go ahead and multiply by 60, which tells me that they are going to meet up with each other again in 10 minutes. Go ahead and try this one on your own. So setting up our table, you end up with 1.2 hours, or if you wanted to convert that, you could say 1 hour and 12 minutes. If you have questions about this or anything else from the lesson, please let me know when you get to class.